Okay, we reached this point last time talking about when we talked about models. Now we will talk a little bit about a review of some mathematical concepts that we know. Okay, so it will be just a couple of things that you already know, but just to highlight some of the things that we are interested in through the kinetic course in general. Okay. So one of the things that you need to take care of, whatever the term that you are using, the units that you are using. So if we are talking about certain concentration, do we know what is the unit of the concentration? What is usually the equation of the concentration? We know that you already have in pharmaceutical calculation and pharmaceutics courses that we have different way to determine concentration depends on the unit that you have, right? Usually, usually we use in for clinical purposes volume mass over volume. So it will be the unit of concentration will be a unit of mass over volume. So for example, um, let's say microgram per milliliter, milligram per liter, anything that is amount over volume. Okay, so if you are talking about concentration, you need to know what exactly the unit that you are talking about. And if we are giving you a certain concentration and volume, for example, are you able to determine the volume? Or sorry, if you have yes, the volume and concentration, are you able to determine the amount or vice versa? Let's say that we are saying that concentration that we already know equal mass over volume. Whatsoever the concentration that we are talking about, let's say whatever we are um, measuring in biological fluid. So it's mass of the drug over the volume of the fluid that we are talking about. Okay, so it will be, let's say, in unit of milligram per liter as an example. Again, okay, so if you know that you have known concentration, this is known, and you have known volume, can you determine the mass? This was my question. Or if you have your concentration and you have your mass of the drug, can you determine the volume of the fluid that we are talking about? Or if you have, I'm just saying, if you are having any of those terms, two terms, to determine the third one, can you determine the concentration if you know the volume and the mass? For sure, you would, because you have this equation, so you can determine any of those. Okay, so you need to know the concentration that the main rule for determining the concentration, what is the unit that we usually use, and again, you know, for clinical purposes that we are using mass over volume, so you need just to be careful what is the mass unit and what is the volume unit, and if you need to change the unit or do some conversion, if your mass is, let's say, in milligram, what you have in the question, but you need it in the answer in microgram. Can you do this conversion? If you're having your answer in liter, can you determine it or convert it to microliter? For sure, those are basics, but you need to be able to know it. And don't tell me in the exam those are chemistry wise or 101 calculation. This is basics that you should know as a pharmacy student. So I consider you as to know those units by default. Okay. So again, the molecular weight of the drug, can you determine for our for this course sake? I will not ask you to determine the molecular weight of the drug, but I can tell you that the let's say the weight of the patient equals let's say 70 kg, and the volume of distribution is equal 2.1 liter per kg. So I consider you able to convert this to that, or using this to convert volume of distribution to liter for sure. So again, those are basics, and I know that you know that those are basics, but I just highlight those basics, okay? Another thing, um, if you, we just mentioned this, if you know certain amount added to certain concentration, what is the volume, you should be able to do that. Two terms and three terms, and you have the equation, you'll be fine. For the following equation, something like this equation, again, we have y, we have x, and we have this multiplied to your x plus this term. What we call this kind of equation? This equation is one of the, no, this we call it linear equation. Can you sketch it? When I say sketch, it's just um, um, approximate drawing, not an accurate or to scale drawing. So if I want to sketch this equation, this one, I will have y versus x, right? Y and x. I have 1.8 and plus 2. Plus 2 will be what? My y-intercept. Okay? And so I will start from here, which is plus 2 that I have. Okay? And then the sign of the term that is multiplied to x is positive. So it will be linear and ascending because it's positive 1.8. Let's do it again with another example. Okay, so if we have y equal minus 2x plus, let's say, 5.8. This is another equation. Again, it's a linear equation, and we know this because it's linear term. Okay, if I want to draw it, I have y versus x. I have 5.8, which means that my y-intercept is what? Positive. Okay, that's why it's above and the positive part of y-axis. So it will be 5.8. Okay, and I have negative 2x. That's why I will have this. It's descending because I have minus 2. So the slope will be negative because the term of that is multiplied to x is negative. Okay, so that's why here was descending, and that's why in the previous one, in this one, it was ascending. And for sure, you should be able to determine according to this equation or that equation, if I give you certain x term or number, what is y, and if I give you certain y, what is x, for sure, because if you have x and y and you have your equation, if I give you 0, 1, 2, 3, whatever the x is, you can be able to do this using the equation. And if I give you different y's, 3.1, 4.6, whatsoever examples of the y, using this, you can be the equation, I mean, you will be able to determine the values of x. So again, it's a linear equation. The whole idea of it, it's a linear equation, so you should be able to deal with it. And we will talk about linear equation a lot, and you'll see when you will use it. But if you know the term out of it, which is y equal ax plus or minus b, and this is plus or minus. We know that this is the, let me just write it in a large their screen. Let's keep it red. So again, we have it y equal plus or minus a multiplied to x plus or minus b, right? This is determine the direction of the slope, right? If it's positive, ascending, if it's negative, descending. Okay, this is would be the slope, which is the number that is, or the value of the number that is multiplied to a. So this is this 2x, sorry. So this is the slope, and b would be according to this equation, which is again called linear equation, is called y-intercept, and it could be positive. This is y axis. If it's positive, it would be here, right? If it's negative, it would be here, okay? Y-intercept. So this is what you need to know, and I'm pretty sure almost all of you know this, but I need to highlight it, okay? Um, if we go, if you have the equation, you need to, like this, you need to know that this is your slope, which is 1.8. If you have 2 points, which is what we call it x and y, okay, or pairs, okay, let's just have it as example here. Let's say that you have y versus x, and we have this point and this point, okay? This is x1, y1. This is x2, y2. If you have two different points, two pairs, and you know that you have linear relationship or linear equation or profile, can you determine the slope? Yes, we know that the slope would be delta y over delta x, right? Which is y2 minus y1 over x2 minus x1, right? So yes, you would be able to determine the concentration from 2 points that you already have of a line, okay? And again, can you deal with log term, which is the natural term or the power of the 10 term, exponent term, or len terms? And again, with the calculator, you'll be fine to deal with all of them, but you need to know the orders for each calculator or for your calculator, and you need to check your manual uh, or your calculator manual if you forget how to do or you're already don't know how to do this. So you need to know how to get log certain number, if log x equals certain number, or the anti-log. You need to know the len of certain number, and you need to know the anti-len of that number. So those functions, you need to just review it from the manual of your calculator. Okay, in this slide, you can see that we have different exponent functions. Um, Again, I just add them usually just to make sure that you know certain basics about the exponents. But for the sake of this course, I will go through whatever I need you to know about this relate to the exponents. For logarithms, we have again the log and we have len. Okay, log is usually to the base of 10, not usually, it is to the base of 10, and len to the base of e. Okay, and usually we just write it log len. Okay, we don't write 10, but you know this by default. Um, For the logarithm, you need to know this, which is very important, that 2.303 of the log of certain number equals the len. Or if I want to, if you have len and you need to get the log, of that number, you need just to have it over 2.303, right? So this number, you'll find it as a magic number because it's what converts log to a len, okay? So just make sure that you can be able to convert log to len or vice versa, okay? One important thing also to remember that either log, the common log to the base of 10 or the natural logarithms, they are not having any units. So they are unitless, which means that you'll find me writing concentration versus time as profiles. Okay, let's say this is again example, and we will see this when we have the IV or the rates of the reaction. Here will be milligram per liter, let's say. If I have it in the log term, it will be log concentration versus time, or len concentration versus time, okay? We will not have unit, so it's unitless. Okay, unitless compared to the unit that we have here. So this is something important that you need to keep in mind. Okay, again, some laws of logarithms that you already know because those are basics, but again, I will go through each and every point when I want you to remember anything. As I mentioned, you need to know how to get the log, the common logarithm, len, antilog, and antilen using your calculator. Okay? Okay. For graphs, in general, you know that we have y versus x, right? Y-axis, positive y-axis versus x, positive x-axis. The whatever is changing with the other one, we call it dependent variable, which is not changing compared to the other one. We call it independent variable. Example that we have: concentration versus time. The time is not changing with the concentration, but the concentration is changing with time. So that's why we call it dependent variable. Okay? Or you can just have it x versus time. And just as a reminder, when I mention without a drawing or a profile, concentration versus time, it means that this is your y and this is your x for sure. And there's no need to tell you that in the exam. Okay? This is an important slide and important note to keep in mind. We have here two type of graphs. Again, we are talking about graphs or type of paper that we usually use to have our profiles. Here, if we start with the first one, which is the rectangular graph, we have the x-axis and the y-axis with same spaces between each numbers. Okay, so the space between 0 and 1, the same as 1 and 2, the same 2 to 3, and so on and so forth. Okay, and the same thing when we are talking about the spaces between numbers on the y-axis. Okay, so that's why we call it rectangular, or for short, graph, from rectilinear graph, or what we call it, this is the same, or what we call it, just linear graph. Okay, and I will just show you in a minute examples or some of those graphs just in a second. Okay, for the semi-log graph, or what we call it SL graph, in which we have, this is your x-axis and this is your y-axis, semi because one of them on the log term and the other is linear. So we have this linear, and the scale of this graph, its scale is log. scale. Okay, and we can see this from the cycles of the log that we have. We have here one cycle and another cycle, and you can directly now it's not linear because the spaces between the numbers are not as in here. The spaces were equal. Here the spaces are starting to be big, then it starts to decrease with as you go up in the graph or in the cycle of the log. Okay, so again, we call this linear graph or rectilinear graph, and we call this simulog graph. This graph, we have linear y-axis, linear x-axis. And this graph, we have y-axis on a log scale compared to x-axis on a linear scale. Okay, let's just show you some